Hi everybody, I'm Dave Bloniers with the U.S. Forest Service, and I'm sorry I can't be here for the beginning of your class where I wanted to introduce iTree to you. iTree is a tool that we use at the Forest Service and many of our partners and cooperators on looking at the assessment of urban trees, whether they be from an individual tree to large scale, being a whole state. I'm going to show you a couple videos here that I put together for you, and I'm going to ask you to write down a few questions that come up to you as I go through the video session, and then I'll be joining you in about an hour and I can answer those questions live. Unfortunately, I double booked this hour. I'm sorry, Rick, but sometimes my bosses tell me what I have to do, and I have no choice. So I hope this works out pretty well for everybody. And I know I put a little time in putting the videos together, so if you just spend a little time listening to me talk about iTree, I think you'll get a whole lot out of it. But you are going to have some questions. I'll be happy to answer those today, and I can answer them anytime as you go through the semester and as you put together your inventory project for your own city or town or the location of your choice. So it's great to be able to present iTree to another audience of new users. I'll see you in about an hour, so thanks very much, and I look forward to hearing your questions. Okay, one of the first things that I wanted to introduce to you was the iTree Quick Guide, which I believe Rick has handed out to you as a PDF file. And this is just for you to refer back to things as you would go through after the lecture, or if you have questions as you see which is the most appropriate tool that you might want to use for utilizing iTree in your analysis or any kind of your research or reporting. And so as we go through and you look at each of the pages in here, this is just a description that talks about iTree itself and what iTree does. And iTree is a tool that helps us to determine and understand the tree and forest benefits, values, and the management costs. Okay, so we're able to estimate not only what a tree or what trees do, but what their function is and how many, and really take an analysis from a variety of different standpoints of trees in our urban settings. And then you can plan and manage to optimize tree and forest environmental services. That means how do you manage those benefits, increase the benefits, and plant trees that are going to provide the most benefits. For example, we can plant a tree that can shade a house or a building, and that will provide shading, which in the summer should reduce your energy costs for air conditioning. Okay, but in the inverse, if we were to plant the wrong tree that blocks the winter sun from getting in, or that solar radiation from hitting a building, it's going to cost us money. So what iTree helps us to do is to select the most appropriate location to actually plant a tree that's going to provide the most benefits both in the winter and the summer. And then we can also integrate trees and forests into green infrastructure strategies on a bigger scale within a community. And then we can, potential pests and insects and diseases can be identified as future threats through iTree. So iTree has a comprehensive list of tools, a comprehensive variety of reporting mechanisms, and it is quite complicated, yet it's very simple. The whole concept is that we look at the structure, meaning what do we have, what kind of a tree, how big is it, what condition is it in, and then we have the function. What is that tree doing? How much rainfall does it intercept? How much cooling can it provide for a building for the summer? How much carbon does it store? How much particulate matter does it intercept? How much sulfur dioxide does it absorb? How much ozone does it absorb? So there's a variety of different things that we look at from that function. And then the value, we convert those functions into dollar values based on a variety of different common trading systems, whether it be carbon storage or others that look at the dollar value relating environmental services to the actual value of a dollar here in the US, or euro over in Europe, or other kind of currency around the world. On the right side of your screen, I'm going to introduce some of these to you, but there's desktop applications that require a Windows-based computer. and that's eco, hydro, and streets. Okay, and then the online applications that work off the web is landscape, design, canopy, MyTree, species, planting, and database. So you're there, Dave. You have about 9 different programs, 10 different programs here. How do you expect us to understand them all? Well, I don't in one lecture, but what I'm hoping you do is you're going to expand your horizons and start with this manual by looking at the overview of each of the products that are there to offer. So the first thing you can always go to is www.itreetools.org, and that's our website, okay, where we have all of the tools spelled out. And this is just the front page of our home landing page. But I just circled here download, and that's where you can download the Windows-based programs like Eco and like Hydro. You can download those there. The other programs are all available via the web, so you don't have to worry about having something on your computer. So that brings into effect your system requirements. The only thing I wanted to say here is any modern day computer will support the download and installation of the programs. And as far as Apple Macintosh users go, which I am, the desktop installations aren't compatible with the Mac operating systems. So, but we have, and I have used things like Boot Camp or Parallels, which is it actually emulates a Windows computer on your Macintosh computer, and that works really, really well. Okay, and then also there are data collection tools that you can use on your smartphones. So iTree Eco is the primary one, and MyTree you can use on an iPhone, an iPad, Androids. You can use it on a tablet, and those work out pretty well. Okay, so that's another option for you as far as how you're going to collect data out in the field. So here's the first program, and this is one that I'd recommend that you try, and I'll try to demonstrate this in a little while. But iTree, MyTree, it's and what I've done is I put this little booklet together for you. There's the what, how, and on each one. So what is MyTree? Well, this looks at how we can calculate the air improvements, stormwater runoff, property values, sequestering and storing carbon, and reducing energy costs. We make a simple estimation of those values, and they're reported out, and you can see right here on the left or in the middle is the MyTree nutrition label. And it really looks sort of like a nutrition label on the side of a cereal box. But what it does with the inputs of location, species, tree size, you get this report that is automatically calculated based on your geographic location somewhere in the United States. Presently, this only works in the United States and Canada. We're bringing it out internationally later this year, but right now it's intended to be a simple and easily accessible tool. I use this with students that I teach in the 6th grade. So this is where I first start to introduce iTree to them, and this is the main tool that we'll use. Okay, this can be used by you on any tree that you find anywhere that you want to look at the value. You can use it on one tree, several trees, or hundreds of trees, depending on what your little study is. This could be appropriate possibly for looking at a collection of small trees. This is where I often use this, that I'm looking at trees on a town common or something. I'll use MyTree for a quick and easy reporting out so that I can understand which tree is providing the most ecosystem service and benefits. So it's generally used in the field to deliver quick results, provided one or more trees, and it's really looking at the how you can report it out in an understandable and easy to understand, viewable visual label. Okay, so that's MyTree. That's one of our easiest programs to use, and it's one I'd recommend that you try out right after class. And the way you access this is you go on your smartphone and you're going to go to the website, and I'll demonstrate where you get it, but you'll just go to Tools and you'll pull down to MyTree. as you're on your smartphone or tablet, and it will launch it automatically for you. The next one, which is really critical, and I'm putting these in the order that I think would be very useful for you in the class, is iTree Design. And what this does, we can place one or more trees on a landscape near any kind of a structure or not near a structure. But the idea is we can, and I'll demonstrate this in a little bit, we can, it's a way and it's a starting point for understanding the value and the function of individual trees or a collection of trees on a small property. Okay, and iTree Design, it's a simple estimation and it's really easy to use. So you input the location, and you can see the green dot there, the waypoint marker, and then you put the species, the tree size, and conditions, and then what it's going to do is report out on the value of that tree and its function. But on this, with design, you can also place a building footprint here, and you can see the blue outline of a building, that's a big residence here. And what we then can calculate is the effects of energy use, whether the tree helps to cool the house in the summer, reduces heating costs in the winter, things like that. And all of the benefits that are reported, we can look at the current year, exactly what it's doing now. We can project ahead up to 99 years in the future. And then we can also look at the projected total benefits from now until that future date we pick. So I fill out a lot of grant applications for a lot of projects that we work on. And I always use iTree to project ahead 10 years to show the grant awardee or awarders, or the people that are giving out the funding to do management. I always show them what in 10 years our forest is going to be looked like. And so, most of the time they're pretty amazed that we're able to project ahead with scientifically based evidence here. This is all based on good science and from our Forest Service scientific science team, as well as university and commercial partners around the country. And then we can also look ahead at the total benefits provided by a tree from when it was 2 inches in diameter up till today. So if I have a 36-inch red oak, I can go ahead and it'll estimate how old that tree is based on the projected tree growth of the location. And we can see that a 36-inch tree might be, 60 years old or 50 years old. And we'll be able to calculate and put out the values of those trees in that time span. So that's another one on iTree Design that we're gonna, that you'll be looking at. iTree Canopy, this takes the concept of iTree Design and spreads it out over the whole community. Okay, so any large geographic area, I use iTree Canopy, in our analysis of urban forests all around the country, and look at, folks don't understand what the percent tree canopy in your community is. One of the ideas, you're going to be doing a project that looks at your community. I would use iTree Canopy to get the information. You can do an iTree Canopy analysis in about 45 minutes just by simply sitting at your computer desk, and I'll demonstrate that in a little bit. So the idea of this one is it's going to report out on the structure, function, and value of the canopy over your whole city or town or large geographic area. So I could do the whole state of Massachusetts, or I could do, the city of Walpole. It doesn't matter. I can pick a geographic area that I define, and in this little screen capture there, you'll see it's the city of Hartford, Connecticut. Okay, and what it does, it lays random sample points that you interpret what is going on those points, whether it's a tree or it's grass or it's impervious surface or it's water or it's soil. You go through and you just check off when you go to each spot. And I'll show you how that works in a little bit. But those are the first tools that I believe would provide you with a great starting point for the course. MyTree, iTree Design, and iTree Canopy are going to give you a big chunk of what you're reporting on the overall values of trees in the community. And then from there, you're going to start to look at individual single trees, which A, you can use MyTree for, B, you can use iTree Eco, which I'll show you in a few minutes, and you could also use iTree Design. I've used all of those. I use all of those, and it depends on the situation and how much time and effort you want, if you want to do a quick analysis or you have time for a more detailed report. So here's the one that you're probably going to want to use for your analysis if you're doing a street tree inventory. It's iTree Eco, and we can look at a single tree, we can look at a complete inventory, or we can do randomly selected plots. Okay, so sample inventory. So one thing I like iTree Eco is I can go ahead and I can do a sample inventory over my whole community, and I actually go out to each tree that is pulled up on our random sample, and I can look at what tree we have, the size of the tree, what species it is, and what condition it is. And by reporting in that, it combines meteorological data and it provides information on the ecosystem of that particular ecotype, whether it be in the Northwest United States, the Southeast, or here in New England in the Northeast. And it really provides tree analysis, either on a collection of trees or on the area you're looking at, but it looks at pollution removal, human health impacts, carbon sequestration, carbon storage. It looks at hydrology, how much avoided runoff, interception, and transpiration, energy savings, biomass emissions, wildlife suitability, and then it goes on and on. You can see these, you can look at those later. But you know, the idea is we're be able to put together a cost-benefit analysis at the end, which will tell us the value of that tree that we can compare with the amount of investment that a city forester makes on their trees in their community. So when you go out and you're going to interview your tree wardens, you're going to get their budget. And one way you can take iTree Eco is to do a sample inventory across the community and show, like we showed in Pittsburgh, Pennsylvania, that for every dollar that was spent on trees, they get $2.94 back in benefits. In Springfield, Massachusetts, we did a little study and we showed that we got over $2 back in benefits. Some cities we go to, we show we get $1.25, $1.30. Generally, we show a positive repayment or a cost-benefit analysis. By spending $1, we're getting over $1 back in value. And that's critical for policymakers like the mayor or city council, town council, or budget directors to look at, because they don't want to waste money. And if we can show them for every dollar we get a payback, that's very, very important, especially in the days of municipal budgets and fiscal management. You know, we're competing with the fire department and the police department and the transportation folks, the public health folks, the school department, all of that for taxpayer dollars. And what we want to show is that, wow, for your dollar of investment, we're getting a positive feedback, positive benefit. So why wouldn't we want to continue that very small amount of investment that most cities spend on their urban forest? Let's continue that or possibly increase that investment, because we know for every dollar we're going to get a benefit. And so you can report out on that using iTree Eco. And I just think that's a very powerful tool. And we've used that in many successful cases, including New York City, Baltimore, Philadelphia, Washington, D.C., Boston, and other countless cities around the country. And so we're able to actually increase municipal tree budgets, which is critical, important in today's world of sustainability, resiliency, and addressing global climate change. Because all of this fits into how we can address global climate change at the local level. Okay, so we can bring it down to improving the environmental quality of your neighborhood, your own property, your own yard, your own backyard. And that really has an effect, because we know that to address global climate change, it has to be done at the local level. The United Nations isn't going to come in and make sweeping changes that are going to suddenly change and reverse global climate change. It's going to be made at the smallest levels in our neighborhoods, in New York City, in our boroughs, in Chicago, in our districts. So it's at the smaller layer, and this is what we can start to examine using iTree. Oops. And then this sort of just goofed up on me. Let me go back. Sorry about that. Okay, so that's iTree Eco. Oh, I'm zooming in. I am so sorry. Okay, let me go back. There we go. Um, it didn't. Okay, so now this is the iTree mobile data collector tool, and this is just available for iTree Eco, and you collect the information on a mobile device, and we'll get more into that as we go. So that's the mobile data collector. The other one is iTree Streets, which is a legacy program. And what we've done, you can still utilize it, but what we've done is incorporate all of the features of this. It was originally intended to do just street tree inventories, but we've incorporated into iTree Eco. So if you're going to use iTree Eco, you're going to be able to get the same reporting. But we do have users who are still using iTree Streets. Essentially, we've incorporated all of the features of this into iTree Eco. Now, this is another one. You probably won't be using this in this class, but it's one of the most powerful tools we have. It's called iTree Landscape. And it looks at identifying locations that would most benefit from planting of trees using demographic and environmental data. So we look at environmental justice, and that's a big issue in today's world where certain neighborhoods have less tree canopy, no access to green space, generally a lower income population, and generally have a degraded quality of environmental health in their community. That results in degraded public health, people's individual health, whether it be asthma or other things like depression, anxiety, high blood pressure, and other components. When we have a healthy ecosystem, we have healthier people. We also have safer communities by trees and green space, and access to green space will calm people down. It will lower their blood pressure. It will reduce occurrence of aggravated assault by making people calmer. It'll reduce the occurrence of domestic violence. Okay, so those are all studies that have been done by a lot of researchers around the world. If at any time you want to talk about that, we'd be happy to. But our studies have shown us that we can reduce crime in communities. And our studies have looked at Seattle, Chicago, Hartford, Connecticut, are 3 examples where just the placement of green space in a neighborhood reduces by occurrence of annual crime rates by up to 16%. So domestic violence by up to 30%. Aggravated assaults by up to 30 to 40%. So these are true numbers really in the value of planting trees. So what iTree Landscape will help us to do is show us where it would be most beneficial to plant trees based on where do the lowest income people live, where do the folks live that have the least education, they have the lowest income. You know, all of those things, the demographics that make up our community and make our community so resilient, sometimes the environment is the only thing holding us back. So when I work a ton in low-income communities working with youth, and that to me is critical because that's where we're going to be able to make change, not only change in the community, addressing global climate change, but also change in individuals. And iTree Landscape has been an instrumental tool in helping communities around the country to do that. So we'll learn a little bit about that. I'll show you that later. iTree Species is designed to help urban forests select the most appropriate tree species based on these potential environmental services and the location you're growing. So essentially what it does, it looks at I want to plant trees that are under 30 feet tall that are going to lower summer temperatures, that are going to reduce the occurrence of ozone, and are going to absorb or collect particulate matter. Or I can look at trees that are going to look at the most energy, reduce stormwater, and produce the most rainfall interception. Whatever those criteria I can put in here, I can analyze. So what I've done is, in the past, and this would be pretty cool for your class here, is to look at the community you're working in and come up with a list of trees that are from 30 feet and lower. That means you can plant them under utility lines. And then from 30 to 50, and then greater than 50, and look at it from a public health standpoint. So you'll go through and you'll choose all the criteria for choosing the appropriate species
that are going to lead to a healthier community. And you can, I'll demonstrate this in a little while. When you look at that, that reporting will be unique, and it's probably something your city forester has never even thought of. Okay, but what a better way to help to have them sell the program of planting new trees in the community by rallying folks that are into public health, okay? So they can cooperate with one of your local health organizations, a local hospital, medical center, etc. And there's also funding available for planting of new trees that are going to make more healthful communities. So the idea here is they don't know, they want to plant a red maple, or let's not use a red maple, that's not going to do too well on the street. But let's say we're going to plant a Zelkova tree out on the street. Well, they're going to plant a Zelkova tree because it has a certain shape and form and it can survive. Well, now, what if Zelkova happens to be one of the trees that can provide the most healthful benefits for our residents? Why not have that on our plant palette of choices that we're going to look at when we go to plant trees along the streets? And my suggestion is that if we have a comprehensive list of healthful benefits, trees that have healthful benefits, we can provide to the city forester trees that they should plant as opposed to planting trees that don't provide any healthful benefit. Okay, so that's very, very important because as we look at public health and the quality of life for people living in the city, because healthful people are less expensive to maintain, okay? We don't have to send our kids to the hospital. Our elderly grandparents don't have to go for respiratory issues. We're not going to get skin cancer because we've shaded our summer areas where people are going to congregate. There's a variety of other things that trees provide related to public health. So why not plant a tree that only looks nice, not only looks nice, it has the features we like, the spring flowering, the fall color, the size, the form, the texture of the leaves, and shape and height and width and all those things. But then on top of it, one of the most important things, it's making your community healthier. So iTree Species will help us to do that. iTree Hydro, this looks at, it's a desktop application, and this looks at the impact to stormwater runoff that goes into local streams and rivers and how trees impact that. So reducing the amount of runoff that goes into our streams and rivers is critical because what it'll look at is the hourly stream flow from gauges that are all over the country. And then we're going to add new trees and show the impact that how the runoff will be reduced, or we remove trees to show potential impact of increased stormwater runoff if we put in a new subdivision, or we put in a new industrial park, or we remove 2 acres of trees to put in a solar field. So we can look at all those different components, and iTree Hydro will be able to look at that through some sophisticated modeling that is based on peer-reviewed science. And it really does produce an executive summary report that's easy to understand, it's useful, and it can be used by planners, by policymakers, designers, and it can be used by the folks that ultimately make the decision on whether to allow the removal of acres of trees or plant new trees. Both. We can use it in proposed areas for planting as well as proposed areas for tree removal. So iTree Hydro is pretty cool. And then we have another one that's pretty cool. It's called the Greenhouse Gas Planting Calculator. And I use this one all the time because what it does, it estimates long-term environmental benefits based on a lot of trees planted in one location. So if I'm doing 200 new street trees in New York City, I'll use Planting Calculator to give me a rough estimation of what those benefits are. So this draws upon iTree Canopy and iTree Design, but it just puts it in a easy to put data in there. But it looks at the simplicity is pretty simple and easy to use. And if we have time, I'll get you to that one. And then we also have iTree County Benefits, which looks at counties. So you may live in Berkshire County, Massachusetts, or Essex County, or Suffolk County, wherever that might be. The idea is it looks at the the benefits of carbon storage, sequestration, runoff, things like that. But it also, and it does it on a county-wide basis. So in many states, we use counties as an indicator of a geographic area. So this is just one that we combine our counties. It makes life easier if you want to do a report that looks at your county. And then we have iTree Harvest Carbon Calculator, another one that just is off of the same programs that we look at, but this is when we remove trees from the landscape, what is going to happen. So we don't have to use all of these in the course here. I just wanted to introduce to you these. And then we have a legacy program called iTree Storm, which establishes a method to assess storm damage, and this is all done on an Excel spreadsheet. It will tell us how much it's going to cost to clean up the storm. Immediately following that storm, we have to give a report to usually our state emergency management agency, and then over to the federal emergency management agency to get reimbursed money from the federal side. And in order to do that within 3 days of the storm, you have to give an initial estimate of the cleanup cost to your state agency. But that cleanup cost not only includes trees, it includes all the other parts of transportation, public safety, public health, building demolition, things like that. So you need to get your data done, collected, and in as quickly as possible. So iTree Storm shows us how to do that, just going out and doing a simple sample of a roadway network in your city, and we can get that information and the totals to them very quickly, accurately. And we've tested this in several tornadoes and hurricanes, and we found that we're within 10% of the actual cost. So this is a pretty cool one. And then, so that's the end of our programs that we have within iTree. And then we have the iTree Support Forum, which is on the website, which I'll take you to in a little bit. The support forum really provides answers to all of your questions through a community of users, including our iTree support team. So I'll show you how to access that, where your questions can be answered. Also, we have people standing by that can answer questions you have via email, and we respond to those generally within an hour. So we have a team of folks that work for the Forest Service and some of our partners that will respond to your email very quickly. You can also call and leave a voicemail message, and someone will get back to you and contact you on the phone if you want to talk to them. And then we have snail mail in case they ask you to send something in from a particular problem you might have in your community. But the idea here is I just wanted to show you a quick guide, and I put this quick guide together because I just thought it was important that we have in this class some way to best understand what's going on with these tools that we're going to offer. So I'm going to end this little portion right here, and I'm going to be around a little bit later to answer questions. So that's what I was going to have you do. Write down any questions that you have, and then I'll answer those for you. So I'm going to ask everybody as I give this talk and the next half of it, I'm going to ask you to... Okay, let's take a look at the iTree software tools, and I've opened up my itreetools.org website. So you're just going to navigate to www.itreetools.org, and you'll be brought to the landing page here, which provides us access to a lot of information. I'm going to ask you to explore this on your own at some point, but one of the best areas we have here are the support and resources, and in here you can go and we have video learning session as well as the manuals, guides, and workbooks, and there's also a bunch of other information within this under your support and resources. For new users, that's sometimes very useful. This tells us what iTree is, and iTree is actually it's an acronym for the Inventory of Tree Resources, Environmental and Economic. So we're looking at the tree resources not only from an environmental standpoint, but an economic standpoint. So we're looking at urban and rural forest analysis and benefit assessment. We're quantifying information, and we're reporting it out from an environmental standpoint as well as an economic standpoint. So that's under your about, and you can read all about it, and any information that you're looking for as far as requirements and things like that. It's spelled out within here. The other valuable area, this is how we get to each of our programs, okay? And there is a link right here under tools to which iTree tool should I use. And if you click on this, it'll be a sort of a question or a tree which talks to you about which tree is which iTree tool is the best use. So individual and small amount of trees, iTree design and MyTree. Okay, we're looking at forests or many trees. We can use county or canopy or landscape or eco. Okay, carbon stored, we can use iTree harvest. The benefits of new planting projects, we're going to use iTree planting. So take a look at that page, which helps you to answer the question of which tools to use. When you've finally decided which tools you're going to use, our core tools are here, and then our accessory tools are down below. But what I want to do is I'm going to start out with the one I introduced to you earlier, MyTree. Okay, and MyTree, this I generally have you open up on a handheld smartphone, an iPhone, an Android, or a tablet. But I'll just show you what it does here on the screen, because you can also use it on a laptop out in the field. So you're going to click Get Started, and when you're out in the field, it will grab your GPS location. But let's just put in something here, and I'm going to put in 22 Lincoln Street. .01105. That's in Springfield. I'll delete this. And let's see if it'll pull up the street near where I am right now. So there you go. It's just pulled this up, and there's my tree, okay? And so that is a tree that is located, and that's the location, and you can tap its spot. I can move the tree to right here. So now I put that tree in front of this property right here. Can everybody see that? There's a house there, and there's my tree. I just tap where I want the tree to go. And then I'm going to, and if you're out in the field with your smartphone, it's going to pull this up automatically. And there it puts in our location. And then I can name a project. So this is going to be test and example. Okay, so now it's going to ask me to select a type of tree. This is an existing tree. Is this tree part of the Trillion Trees campaign, which is a worldwide effort to plant a trillion trees? Because we're not planting, it's an existing tree, so I'm going to say no. The tree species, so I can type in here, I can look by common or scientific name. But I happen to know that tree, and it's a sugar maple, so I'm just going to go sugar and see if I can pull up. There's sugar maple. Okay, and I can do this on a pull-down menu right on my handheld. And I'm going to say it's in excellent condition. And its trunk size right here is 34 inches in diameter. I can also use circumference, but it's 34 inches in diameter. It's in the full sun. And is it within 60 feet of a building? And I'm going to say yes. Okay, how old is this building? This building was built before 1950. It was actually built in the 1700s, or 1800s, excuse me. 1896, these houses were built on Lincoln Street. How far is it from the building? Well, I'm going to know that when I'm looking at my map, when I'm looking at my air photo on my smartphone, or if I'm out in the field. But I know this is about 22 feet away, so I'm going to say 20 to 39 feet. And the compass direction from the tree to the building, I'm going to be heading north. Okay, that means that the tree is on the south side. So I'm going to go, I'm actually heading northeast from that location to the building. And then we'll just call this Federal Square, Historic District. That's where it's located. So I only can fit that in, okay? And then I'm going to go here, and how stressed is your tree? You can log data here if you want. So I can go and I can look at dieback. So let's just say we have, and you don't have to do this, but let's say there's fine tree dieback of 20%. And then I can look at the leaf discoloration is going to be low, defoliation is low, crown vigor is going to be high, crown transparency is going to be low. And then pest symptoms, wood damage, no, eduation, no, decay, no, leaf loss, no. This tree's in really good shape. Epicormic shoots, we're going to say no. And then I go all done. Okay, so now I have my data that is recorded right here. My Federal Square Historic Project. I have a sugar maple. And now I can go and I can add a new tree. Or let's just add another tree. And so I'm going to go here and I'm going to add this tree. Okay, so I'm going to describe this. And let's just say that this is the same thing, the same project. It's going to be existing. And look here, we could even, if you want it to be a memorial or specimen of heritage, let's say it's a heritage because it is in the historic neighborhood. It's not part of the campaign. The tree species, it's going to be another sugar. Okay, and its condition is going to be excellent. And this one here is going to be 28 inch. And it's in the full sun. It's yes. And it's going to be built before 60 or 50. How far is it? Again, it's comparable to the other one from 22 feet. Estimate the compass direction is northeast. And then it's going to be Federal Square. Okay, and on this one, we don't have to, so I'm going to skip the health and pest, and we'll see what we get. So now I have both trees, and I could look at the first tree and just click here and get my benefits. So the benefits of our first tree, which is the sugar maple, $7.17, okay? I can go to the second tree, and it's $5.39, okay? So we have both of those, and then if I want to calculate all the trees, this puts it together right here. So the total benefits of $130, and it spells it out here, and it shows where the research comes from to create this, the data. Okay, so you want to look at stormwater runoff. This is going to reduce it by 1,071 gallons. 5,900 gallons are intercepted. Carbon monoxide, ozone, nitrogen dioxide. So you can go and you can experiment with this, but I would use this as part of your calculation or to do a few trees to just get the feel for what is calculated when we use iTree. Okay, so that's the first program, and this could be useful also as you carry out your project. When I do this, what I generally do is I can print this out as a PDF, and sometimes I'll grab the screen capture of that particular image. Okay, so that's one way to report it out and include it in your report. So now let's go to another tool, and remember, write down a question that you might have, and I can answer these when I get over to you. So we have my tree. Let's look at my iTree design. This is where we look at an individual property, and we can assess the structure, function, and value of individual trees on a particular place. So let's take it, and I'm going to go back, and let's go to 357. I've never been here. Let's see what's at 357 Armory Street, Springfield, MA. Let's see if it shows anything. Okay, there it is. And hopefully it shows us a little, oh, I'm in the middle of a highway. So that's not going to work. So let's go to, this is where I was born, 1,000 years ago. So now we're going to 33 Atwater Road in Springfield, Massachusetts, and I can zoom in on this particular house. Okay, so there's the big house, so there's the house. Okay, what I want to do is we want to look at the trees that are on the property. And we can look at existing trees or proposed trees. But let's just say we want to calculate energy costs. We click yes, it comes up with this toolbar. And now I have to actually trace the house. Okay, so I'm going here and I'm tracing the building footprint of this house. And there's the house, and it was built in 1920, so I'm going to say that's okay. So now I have the house, and now I can go place my trees. Now this is either going to be an existing tree or a planted tree. But I happen to know that this on the left corner is a big silver maple. So what I'm going to do is go here, and I'm going to look for silver maple. There it is. And this happens to be about a 30-inch, and it's in good shape, and it's in the full sun. And so then this now popped up with the energy savings net. I can get rid of that. But if I was going to propose planting a new tree, what I would do is go to one of these areas here that are the darkest green, are going to give me the most appropriate place to place a 30-inch silver maple. But let's see if it changes. But let's just plant a 4-inch silver maple, and see if it gives me any, see the green changes. So because it's a smaller tree. But because I'm not planting the tree, I'll toggle this off, and I'm going to go back to my 36-inch silver maple, and I'm going to place it where it's actually growing. So there it is, and it just says it's a silver maple 36 inches. And so I placed that tree in that location. Okay, so now I should be able to calculate the value of that tree and what it's doing for the ecosystem services as well as energy costs. But let's also go ahead and look at another tree. So I'm going to add another tree. Let's get one of these. This is small dogwood. Oops, sorry, I got to change this. So I'm going to go here to dogwood. And let's just say it's a flowering dogwood. And it's only 14 inches in diameter. And so I'm going to place that one right there. Okay, so now I have 2 trees. Oh, okay, see, the crown can overlap. So there's the 2 trees. And I can model these future growth of the crowns. Watch, if I click this, this will show me the crown and how much bigger it will get over the next 50 years. Keep in mind, if these were 2-inch diameter, they'd keep growing bigger. But this is giving me, there's crown overlap between the silver maple that's impacting the dogwood. So you can look at that. It's just kind of a neat little thing for proposed trees. And then I'm going to estimate the benefits of the trees, and let's look at them over the next 30 years. Okay, I can choose any year between now and 99. Okay, and it says save your project before calculating. Okay, so right here, I'm going to go to save process, and it's called My Tree, and it's going to ask me where I want to save it. So it just downloaded into my downloads folder, so now I wouldn't lose it. Okay, and on the right side here, there's our trees, okay? And then our structure is in here, okay? And you could delete or add, delete those from there. But let's pretend that you had 10 houses, because you're going to use this tool to calculate the values for your whole neighborhood or part of your project that you're going to be using for this class. But let's look at it over 30 years, and I just go to calculate, and this goes up to the web, it goes up to the servers, and it takes a few minutes to calculate if you have a lot of trees. It says calculations remaining 146, 72. It can take up to 5 minutes if you have 30 trees or more. Now I'm at 80%, and usually it does 10 trees as quick as 2 trees, but beyond 10, it takes a little longer, and when you're up to 30, it could take up to 5 minutes. So look at this, and you're just going to have to wait a second here, and this will come up with our reporting, which is simple and easy to understand. It provides useful things to include in a report, and for this course, there's useful reporting that can go a long way to provide information on the trees that you're studying. So here's our display for all trees, or I can look at one single tree individually, but this is for all of our trees, and this is the current year 2021. So they're providing us an overall benefit of $61 this year, and that comes with summer savings right here of $42. And it provides all these other values here based on stormwater, winter savings, air quality, and carbon storage. So take a look at that. If properly cared for, they'll provide $73 worth of annual benefits in 30 years. So if I want to go and look at the future year, 30 years from now, there it is. That spells it out. But let's go back to our current year, and we'll look at stormwater. So these two trees intercept 4,600 gallons of stormwater. If I want to look at just the silver maple, that intercepts 3,600. And let's see what our dogwood intercepts, 1,052. Okay, so you're already looking at, and it explains here about urban stormwater runoff. Then we can look at energy savings. Okay, this year your selected trees will conserve 179 kilowatt hours of electricity. Okay, but in the winter, it's going to cost you money because they're going to be preventing the sun from solar receipt on the building. Okay, and that's why it's very important you understand that trees can provide benefits, but they can also cost you money. Okay, so these are costing us a little bit of money, and it's primarily probably because this is the south side of the house. That sun is getting blocked in the winter by the dogwood. And dogwood has a dense branching structure that will shade this part of the building. That'll allow no sun to go in through the windows and heat up the inside of the house. Okay, so that's very important, that it's costing us money, those trees, which isn't all bad because we're already saving 179 kilowatt hours in the summer. So you balance these. And then we look at air quality from ozone to volatile organics to carbon monoxide, and then sodium dioxide, as well as particulate matter. This is particulate matter, and it shows us each of the trees here. This is avoided and removed. Those are the totals and the amount of money. And it tells you here the estimated total removal of pollutants is 4 pounds. Okay? If we go to the future year, we'll see that increases to 5 pounds. Okay? We can also look at the total that so far, since the trees were 2 inches in diameter. I mean, between now and 30 years, it'll be 121 pounds. And the date from when a tree was 2 inches till now was 153. So you can look at any of these here, and so far these trees have intercepted 166,000 gallons of water over their lifetime. But let's go back to the current year and we'll look at carbon dioxide, and it's going to be sequestered and avoided. By sequestered, that means stored in the wood. Avoided means we're saving energy, so there's less energy needed, which means less use of electricity, which means less emissions at the generation plant. So that's where we can avoid that atmospheric carbon dioxide. And here we've estimated we've saved 596 pounds to date, and over here we've stored 18,640 pounds. So there's what you have from then, the future year. It gives us those numbers, and let's see what it's done to date. So far they've stored 18,640. So this is another tool, iTree Design, that I hope you will be able to pick up and use in the course, and it was going to help you to get some data and information. The next tool, and this will be the last one and I'll wrap up, is for today, is going to be iTree Canopy. And iTree Canopy, it looks at the tree cover, the benefits that are provided, and it does it over a big geographic area. This is Washington, D.C. down in this picture here. So we actually draw the boundaries. So it could be, Brighton in Boston, or it could be Beacon Hill, or it could be the city of Cambridge, or it could be the town of Wellfleet. Whatever you want to do, you can look at. So let's get started here. And I'm going to pull up our sample project. And this is how you can learn the best and the easiest way to learn how to use this thing. So click example project, clear all the data, and open the example project. And I'll say yes. And this is a project I did in Hartford, Connecticut. Okay, so what's going to do is it's going to, this is the survey. And you'll see here, I can zoom in. And you'll see here, this is the red line, which is the geographic boundary of Hartford, Connecticut. Okay, that's the first thing we have to do is draw that in or get that data from somewhere. And I'll show you how to do that in a minute. But then what I do, these are the results of what we've looked at. And if you look here, you'll see I have 50 pages of data. And so if I go to the last page, you'll see I'm at point number 500. And what I've done is classify each point on the map that pulls up randomly, and I classify it by a series of cover classes. And we're primarily looking at where we have trees or shrubs. So let's go and we'll click a new one. And there it zooms in to a point on the map or on the air photo. This is using Google Air Photo. And so what I'm going to do, the cover class for this, see the little crosshairs right there, right in the center, whatever that center point, it's going to be point number 501. That's going to be a tree. I'm going to go save and create new. That right there is an alleyway between two buildings, so this is going to be impervious road. I'm going to create a new one. That's the rooftop of a building. I'm going to go through here, impervious building. I'm going to go to the next one. That's going to be a tree. So what you need to do is go through this, and you're going to do from 300 to 500 points of the community, the area, or wherever you want to analyze. And there's a building. So I just keep going through this, and this can take you about 45 minutes to do 500 points. That's a field, okay? It's a crop field, so I'm going to just say that that is grass. Okay, so I can classify these at the beginning however I want. That's an interstate highway. So that car is going to hit my marker in a second, but I'm going to just go here, and I'll do one more for you. Again, we're in trees, so there's another tree. So now I go save. Okay, so there's what I've got. Now I have 509 points. I can go back to the beginning. I can edit these points if I need to change it. I just click on here, and I could change this if I made an error, but I did this so I don't have to. And up here, it starts to give us a little idea, and this right here is showing us area covered in square miles. And so this is 4 square miles, so we have over 4 square miles of trees. This is our trees. And then the percent canopy cover, you can see here on the left, this is 20%. This is somewhere around 36%. I think it's at 26% is the actual number that will come out of this. But let's take a look at that as we go. So let's click here. We click at the report, and here's what happens. It gives us a little summary report here. Now keep in mind this right here, you see this? This is telling me that we have 4.73 square miles of tree and shrub, and it's 26.33% of the canopy cover in the city. And so in this case here, we're always looking to try to find about 40% tree cover as a minimum in the community. Okay, so we can see here we're 14% behind a canopy goal that we can establish for Hartford, Connecticut. So always look at what your tree canopy cover is and see what you have in your community. Ideally, we're looking, the Forest Service and some of our research partners look at 40% as a threshold that we'd like to see communities get to. Okay, and so this tells us what each one of these, this is impervious road, this is impervious other, this is impervious buildings, this one here is grass, this is water. And then you can also see on here where those are distributed on this little map here. And you can zoom in on the map, to see where each of these items or each one is located. You can look at it from a map standpoint. You can look at it from a satellite standpoint. So that's a little cool feature that we have here. But now we have the reporting right here. This is the one we're mainly looking for, is tree, shrub, and here's our answer right here. Okay, and our standard error here is 1.95, so that is meets our statistical threshold, so that makes it good data. And we're looking at our standard error over here is 0.035 or 0.35, which meets our threshold. So the idea here is now we can start to look at the benefits as we go through here. So how much carbon is stored or sequestered, and how much is stored, and these are in tons, okay? And so we have the CO2 equivalent, the value, 550,000. This is $17 million in value total of storage of the tree, carbon in the tree, $17 million. So if we're looking at addressing global climate change, carbon storage is one of the key indicators of what we need to do, increase carbon storage, okay? And then here's our benefits, okay? Tree benefits, air pollution, carbon monoxide removed annually, amount 3.3 tons, okay? The value of that is 2,000. Ozone removed, 57 tons, that's worth 77,000. Particulate matter less than 2 microns, that's the size that gets into kids' lungs. That value is $156,000. Particulate matter valued at 27,000. So these are tons. So 81 tons of dust and gases are taken out of the air, which is a whole lot of healthful benefits. And then the other benefits here from a water standpoint, we're avoiding 21 million gallons of avoided runoff. We're intercepting 225 million. That means it's held in the trees and never even hits the ground. Potential evaporation, 118. This is 18 million, or wait, this is 1.8 billion gallons, and potential evaporation 1.3 billions. Okay, because this is in millions of gallons they're reporting. Here's the value. We don't calculate this, but $192,000 can be calculated from the avoided runoff. If you want to look at where we get these, it's all backed up in the reporting, and as well as some little descriptions are down here, so you can look at that to get your analysis. Okay, and then what I can do is this report here. I can either screen capture, or I can print or save it as a PDF. And then we have all of this reporting here on our canopy. The one thing that I'd advise you for the class to do is to look at your community, spend 30 or 45 minutes doing 300 to 500 points, and you'll have to add this to your report. And it's going to be really important and valuable, because I want to see what you have, and here's other information if you're looking for it, you can get to it. But let's go to, and you can export this, all your data, you can export it, you can save it, and you can reconfigure it. So I'd like to see what you get for your own community. But let's go home for 1 second. I'm going to get started here. And let's, I'm going to have to, well, I can't. I'm sorry about that. What you're going to do, I'd have to clear my cache. Let me clear my cache for a second, if I can. Hang on. In Chrome, I'm going to go over here. I believe if I clear my cache, because it's going to hold this project, and I'm just doing that right now. Okay, I just cleared my cache, so let's go back to iTree, Canopy. I'm going to go here. And I'm going to get started. Okay, so there you go. So now let's create our own location. So what I'm going to do here is I'm going to go to Springfield, Mass. And you're going to put your own community in. And there you go. This is going to pop up. And so what you're going to want to do at this point, oops, is you see your boundaries here, so I can go to show the census places, and it should pop up. Hang on. I'm gonna go here to, wow, it should show it. It's not, let's see. There it is. Okay, so there's Springfield, and it's all been selected. So now I'm gonna go to next. And now here's our basic land cover. So I can go here and click that, and it will give us this listing here. Or I can just go to tree or no tree. Or I can go to the basic land cover and I can add something in here, and I could put like a cover class of swimming pools if I was counting swimming pools. But you can put in whatever you want. You could change this to grass and take out the word herbaceous if people don't understand it. So I could go ahead and edit this one, and I can just go here and I can just take this out, and let's just call that grass, okay? And so you can change those or make those up, and if I want to delete one, you just throw them in, and you could just have all impervious. You don't have to have the three. You can do whatever you want to understand what's going on in the community. You go to next, and then we're going to put our location here. We're going to have the United States. We're going to look at urban. It's going to ask me where we are, and there it is. It's in US dollars. And so there you go, and the measurement, and here we go. And so now I'm going to have it start my canopy, okay? So I can zoom in a little bit. So let's zoom, well, I don't need to, because I'm just going to go here and I'm going to add my first point, okay? So I'm going to look here, and you can see the whole map, your whole area here, and I'm going to add the next point is going to be the little plus sign, which is right here. And there's my first point, okay? And it's going to show up right in the center of the map, right there, and it's a tree. So I'm just going to go here and leave it, and I'm going to add a new one. And that's asphalt or a paving, so I'm going to go here. Okay, and then your next one is going to be, that's a driveway. So the same thing, I'm going to have impervious road. And then the next one is going to be a tree. And the next one is going to be right there in the middle in the road, you see it? So I'm going to say that's impervious road. And then the next one is going to be impervious road or other. Let's just say that's other. It's a parking lot that's in sort of abandoned. And then that's going to be a tree. So it comes up. That's going to be grass. So I'm going to go here. And I do this for 500 points. That's going to be a building. Okay. And what you can see here, if you look up here, this is our confidence interval. See how far these are apart? You want to have these bars come down close to each other, close to the top here. And that means you're getting more statistically valid results, okay? So right now, I've only looked at how many trees do I have. Let's just save it. And I've only looked at 10 trees, okay? And so you have that to be able to look at. And then I can go ahead and save my report, or I can print out my report. But this isn't going to help me. There's where my trees were located in the city. So you can see where they were. And on a map, you can see where they were, what neighborhoods. But in my confidence interval and my standard error is very high right here. Can you see that? Our standard error are way beyond the bounds we're looking for. So what you need to do is keep going. And I usually stop at around 400 and see where these confidence interval and the standard error are. And then from there, what you do is you can stop your whole analysis and go do your reporting, and you're going to get numbers. But keep in mind, this isn't statistically valid right now because we don't have enough points. So the easiest way to learn this is to go back to home, and you can and you're going to get started. Sometimes you have to clear your cache because it pulls up the last project. But I would look at our example project, and you can see here, we can go here and you can start over, clear all the data right there. I can clear it that way, get started, and I would launch our example project and start to examine what that looks like. You can also load shape files, which are GIS boundary layers that you can get from, in Massachusetts, from MassGIS, or I can go ahead and draw my own boundary here. So let's look for Springfield. And suppose I only want to, oops. I can then go and I'll zoom out a teeny bit, but I know the areas of how Springfield is shaped, but I can go ahead and do this. And you know, you can go ahead and you can do your own community. Oops, sorry. And you can spell this out like that. And now there's Springfield, okay? So you can do that, and you might have only a neighborhood you want to isolate. So you can draw boundaries of whatever you want, okay? And I can delete those. And I think they're gone. There it is. Okay, so you can start over, and I can now draw a boundary that's a bigger area because I'm going to include all these towns. Oops. And I did all these towns east of the Connecticut River, say. And there you go. And then from there, you just go to next. You're going to continue. You basically can click next, next, next. And we're just going to have to click here on the United States. And one thing, if you want more accurate results, you can click down to your particular state that you're in. So you can go down here. This will even itemize it a little further. So we can get to Massachusetts. And I'm in the urban. And in Massachusetts, I'm going to go to what county I'm in. So here, I happen to be Springfield's in Hampden County. I'm going to go here to urban. And I have all that. And I'm just going to go to next, and I'm ready to start. So here's my first spot. It's not obvious, but go right here, click on that, and there we go. It pulls up grass, and I get started, finish, print my report, and examine it. So that's the few of the tools that I wanted to introduce to you today. The other one that I want to introduce and show you is iTree Eco. So I'll put together a separate video for that.